By now you should understand most of the basics involved with using the bash environment. And as a result, it's time to move on with writing our first script, and it's the classic Hello World script. Most programming classes or materials begin with the simple Hello World script. We'll do so with a twist. We'll show you various ways you can implement a simple shell script and some of the techniques that we've taught you thus far, such as redirection, you name it. Let's open a shell, and we'll show you some ways you can get going. We'll navigate into the temp2 directory. That's where we've been. It's a clean directory. It has a few files, including data, which we've looked at, the testing directory with a space, some text files for Hello World, you name it. But let's go off creating our first script. Now, all we want to be able to do is to echo Hello World to the screen. Typically, you could do that from a shell, as we are currently here, simply by typing echo hello world. This would echo back to us, as it has, hello world. So you may be wondering why put it in a script. Well, within a script we can make use of what we've learned thus far. So the first thing we want to do is use the touch command or your favorite editor. Now if you prefer a graphical editor, consider, like, for example, gedit. You can run gedit to create your script, or a shell-based editor such as Nano or Pico. Nano is a Pico alternative. I'll run Pico since we're on this Red Hat system and Nano is currently not installed. VI is also an option. And it's a new buffer, and we need to define the script. Now, all bash scripts, including Perl scripts, contain a header. And that header tells the shell environment what interpreter is responsible for processing the contents of the script. The way you specify the header is with the pound sign, and then an exclamation mark, and then the path to the interpreter, in this case bin bash. So once again, whenever you start scripting, whether you're writing Perl scripts, which you see on CD2, or bash shell scripts, you begin with a header that declares to the interpreting shell environment the location of the interpreter, so that it knows what to process. Because if we didn't put, for example, the interpreter at the head of the file, then after creating the script or populating this file with the contents necessary to run the script, the interpreter wouldn't know which, or the shell environment wouldn't know which interpreter to execute. It could be any interpreter, and most Linux systems ship with multiple script interpreters such as Perl, Bash, etc. So bin bash, this is how you typically want to do it. Now, good practice is to also include an end line. However you want, it could be uppercase, lowercase, doesn't matter. It's a good idea to have a line that says end for visual purposes. Not necessary. There's nothing that requires putting end. It's just clean. When you see it, you know the script's finished. Now, in here is where we would place between the opening declaration of the shell interpreter, or of the script interpreter, which in this case is bin bash, and the end statement. Again, the end statement is not required. Now, pound signs or hash marks within a bash script, and for that matter many scripting environments within the Linux environment and Unix environments, are considered comments or remarks. So most interpreters know to ignore the pound sign, the hash mark that you see here, with the exception, of course, of this very first line, the shebang line. This very first line is special. It's a pound sign immediately followed by the exclamation mark, and the interpreter knows that, or the bash shell environment knows that it needs to launch a specific instance of the interpreter. Another thing you should know is that scripts run within their own shells. So by virtue of declaring the necessary scripting interpreter, as you see here, bin bash, the environment that we're in will launch a subshell to run the script. So the script, whether it contains one line or a million lines, will run in a subshell of the shell that we're running in. Excellent. So what do we want to do? We want to just do a simple echo space hello world, nothing fancy. And that's it. Let's exit. We'll control X, and we'll need to save this, and we're going to write it to the current directory, which is temp2. We'll save it as hello world.sh. There's no requirement, no extension requirement within the Linux or Unix environments. However, it's syntactically pleasing or visually pleasing to see an extension that corresponds to a particular interpreter. For example, when you see .pl extensions, you know it's indicative of a Perl script. Excellent. Not that it necessarily has to contain Perl scripting or Perl scripts, but typically that is the case. So in other words, what I mean is we could save hello world.sh as hello world.pl, but bash would still process the contents of the script because the declaration at the top of the script instructs the bash environment to call a bash subshell and not Perl. But we'll be saving this as hello world.sh. It's now saved, and if we do an LSLTR, LTR shows us the last created entry at the bottom. We have a script that's 40 bytes. However, although it shows up green, and that's only because it has a recognized extension, in this case .sh, although it's colorized, it's not executable. If you notice here, it's not executable. Now, there are two ways we can go about making this particular script executable. We can run the source command, which I mentioned earlier, or we could flag the hello world.sh file as executable and then run it from this directory using //. Let's show you the first way, which is to run the source command. So as you see here, you just simply type source, tab it out, and then we'll tab out hello world.sh. This tells the bash interpreter to process the contents of the hello world.sh script file. Let's proceed. Now, when we run source space hello world.sh, what does it do? It does exactly what the script tells it to do. Echo space hello space world. That's all it does. It's quite simple. Now, let's try to run the hello world.sh script the conventional way, which is to specify the current directory by specifying // Unlike DOS, which executes by default executables from the current directory first, bash does not. So you need to specify //. // is typically not in the path of most Linux distributions. So we specify // which means this directory, and we'll try to run hello world.sh. Now, if this file were executable, when we press tab, we would see the content. We would immediately benefit from tab completion, thus being able to see the contents of hello world.sh. But because hello world.sh is not flagged as an executable file, it doesn't tab complete. So currently I'm tabbing, or I'm pressing the tab key, and it's not working. You can manually try to type it out and execute it, but by the very virtue that tab completion is not working tells us that the file is not executable. Now, any file can be flagged executable, and will attempt to run. The shell will attempt to run it. So let's try to do hello world.sh, and as you can see here, permission denied. And if you'd like, you can echo from our previous discussion the error level, and any permission-related error comes back as an error 126. If you did it again, it's going to come back as 0 because the echo command was successful. So let's flag hello world.sh as executable. It's quite simple. Run the chmod command, chmod, and you can add the executable attribute by doing a +x. But if you do a +x, then everyone will be able to execute this file. So let's say we only want the root level user to execute this file. We can do u+x for user +x, or we can use the octal notation, the numerical value. User +x, hello world.sh. And now, when we lsltr again, or just simply lsl hello world.sh, you'll see that it's been flagged executable, and only executable by the root user, or the owner of the file, in this case root. Now let's try to run it with // hello world.sh, and it runs. It echoes for us hello world. You want to get a little bit fancier? Modify the file and perhaps clear the screen first. Now, shell scripting can be very simple and can become very complex, but in its default nature, it's just line separated commands. So one command after another, and they run sequentially. It's as simple as that. No differently than how you type it on the command line. At least that's how you begin. But of course it grows more complex. Now let's try to run this file again. And it clears the screen, and it echoes for us hello world. We can run it again, it'll do the same thing. We can make a mess and then run the command again using history, and it clears it. Excellent. Now what else can we do with the hello world file? Well, we can still source it. That'll still work, so that you know, if you're wondering, will the source still work now that we actually have flagged the file executable? Certainly. Just run source and you'll see it works just the same way. So now we have two ways to run the same particular script. Now what we should do is try to get fancy with the script by doing different things. So what we'll be showing you next is how to use variables within the hello world.shell script file. That should be pretty easy, and you know that in order to set variables you simply type the name of the variable, such as var name, with no spaces is equivalent to a value. We're going to set variables, we're going to echo the date, we're going to get the output of the hello world file. We're going to do a few things to make use of some of the things we've learned about the bash environment, such as redirection, piping, etc. So let's jump to the next section where we will make use of those other things with hello world, and then once we have hello world out of the way, we'll move on to more advanced stuff. So we're now ready to do some more things with the hello world script. Let's use Pico to modify it. And we open the wrong file. We need the shell file. We have two entries here, two commands, clear and echo hello world. What else can we do with this particular script? Well, it depends on what you want to do. The art of shell scripting is determined by the task at hand. Typically you write scripts to complete or to perform a certain task. Well, in this case we're just learning, so that task or those tasks could be anything. Well, let's show you how to use quoting, for example. We can echo hello world using conventional double quotes. And let's exit to show you that. It echoes just the same way. So the values have been preserved, nothing's changed. Now let's look at that again. We're just rehashing some of the things that you should have learned. We're doing hello world and we're using quotes. How about putting a dollar sign? Will the dollar sign come out? Let's see. It comes out. However, you should know that if we were to put a value, let's try putting a value such as value. Let's see what happens. Without spaces, it disappears. Just to show you that the concept also applies to scripts, because remember, scripts simply launch subshells. So let's go back, and if you wanted to preserve the values that are in here, what do? Take off the conventional quotes and you go with single quotes. Let's try that again. And as you can see, everything has been preserved literally, including the dollar sign and the word value. No substitution, no variable or parameter substitution was attempted by the bash shell because it encountered single quotes. Those are some of the things you can do. Let's look at the variable side of things. Let's say we wanted this message to be stored in a variable. Well, typically it makes sense to declare variables up front, variables that you're likely to use throughout, or at least global variables, throughout the scope of your script. Now within a bash script, you can define global as well as local variables. Local variables typically operate or live within the context of a function, and we'll be showing you how to define functions. Functions are quite easy to define and use. Global variables, however, are just basic variables that are set outside of the realm of functions and can be used anywhere throughout the script. Excellent. So let's say we wanted to store the entire hello world value in some sort of variable. Well, we need to come up with a variable name. Let's call that variable name, for example, message. So we can say message is equivalent to, and as I mentioned before, it's a good idea to capitalize your variables. You don't have to, but it's more readable. So we'll say message is equivalent to, and we can use quotes, hello world. Now if you're wondering why, you'll see shortly. We've set this up purposely. Now instead of echoing the word hello world, we're going to echo the variable message. But you should notice one thing. We still have single quotes. Let's leave it like this and see what happens, just to reinforce the message. Excellent. So we're asking bash to clear the screen and then echo the message, which is equivalent to hello world. Let's see what happens. So we try to do hello world.sh, and what happened? Remember, single quotes preserve the entire message, the entire string within. So let's modify this file again and make the requisite changes in order for this to work. We'll get rid of the single quotes and use double quotes. Double quotes are, remember, considered weak quoting. They work almost as good as single quotes for most values, with the exception of $ and the escape character, the backslash, and a few other characters. Let's see what happens now. Hello world is echoed. Now we don't need to keep opening the script with Pico if we're not going to make changes. We can just cat it and you can see the contents. So at least we're still within the shell. So we're able to echo message nicely because we used, in this case, double quotes instead of single quotes. Now you may be wondering, can I echo the variable without actually enclosing it within quotes or wrapping quotes around it? Let's see. We'll take off the double quotes. We'll return to the prompt and attempt to run it again. And of course it works. No problem. Quoting just helps if you need to preserve some of the, once again, the characters. You don't want it to be interpreted. And if you need strict or as little interpretation or no interpretation, use single quotes. So let's see what else we can do here. Let's modify hello world.sh. There are a world of things we can do. Let's show how to use a comment within a script. These are very basic examples, but remember, what differentiates larger, more functional scripts from small, simple scripts like, as we're working with here is nothing more than more lines of code. So if you can work with a few lines and grow, then you'll learn. Here's how you comment. Simply put a £, and clear will not run, or that particular line will not run. And let's show you. Notice the screen was not cleared. We can keep running it, and it has not cleared. Excellent. Let's modify it again. See what else we can do. So we don't want to clear the screen. It's commented. Here's another good thing to do. Right beneath the definition of the interpreter, it's a good idea to put a few comments and describe the script, including date information, etc. So it's a nice idea to put something such as the following. And you can put author. This just makes it readable and understandable for subsequent users of the script. So this is nice. This doesn't hurt. And the information here will not be echoed. We'll show you that. No sweat. So we have some comments up top. Only the first line is important or special because it contains the exclamation mark right next to the % and the name of the interpreter. What else can we do? There are quite a few things. So we've set hello world as a variable and we've echoed it. We can set multiple variables if you'd like. Let's set another one, message 2. Let's say the world belongs to me. And we'll close quote. So now we can echo right next to message 2. Let's see what happens there. So now we're working with two variables. And this is a little formatting error. The world belongs to me. Bring this down a line. And we want to echo message and message 2. Let's see what happens here. Now this is all on one line. Makes sense because that's how we told it to echo. If you want, you can separate them by a new line by echoing a \n, which is the escape character for a new line, or you can just echo it on a new line. Let's show you how that works. Quite simple with a different echo command. No big deal. Just echo it on a separate line. Now we have two lines. Hello world, the world belongs to me. Two separate variables. So we've set two variables. Quite simple stuff, no big deal. Now what if you wanted to do some piping with this particular file? What if you wanted to send the contents of the file to some sort of processor, some other utility? Well, you run hello world and proceed with what we've taught you thus far about piping. You can pipe the output of hello world or redirect the output stream to someone else's or some other process's input stream. So we can say hello world.sh. Let's say we wanted a word count. We can send it to WC. This would give us a word count. If we specify the lines option, it would count the lines for us. So here we get a count, number of lines, etc. Or we could do -L, and -L will count the lines that it finds within the file. And this is based on what's outputted. If you're wondering why does it only see 2 lines, well, think about it. When you run hello world, it returns 2 lines. So think about what we're doing here. It's quite easy to get confused. We didn't actually cat the contents, or we didn't echo the contents of the hello world.shell script. We sent the output of hello world.shell into some other utility, in this case the word count utility, which decided to count the lines. And if we sent it to it without any options, well, it can count the characters for us, and you can count them if you want, including spaces. Spaces are characters, so it counted the characters, it counted the number of words that it thinks are there, and it's exactly, I mean, it's right. Just count them. It sees 2 lines, 7 words, 36 characters. Well, 1, 2, 3, 4, 5, 6, 7 words. So word count works pretty well. These are pretty seasoned tools. So we've outputted the contents to the WC command, and it's told us that we have 2 lines. We can do more with this information. We can run hello world, and instead of sending the output to screen, we can use the redirect, the output redirector, and send the output, which will include hello world, the world is mine, the world belongs to me, into a newly created text file. We can call this file, let's say, hello world, and there are a few that exist, so let's just overwrite one of them. We'll send it to hello world.text. Recall from what we showed you before, when you use one redirector, it overwrites the file. So this hello world.text file is going to disappear. Now we can cat the contents of hello world.text, and it now contains hello world, the world belongs to me, etc. If we use 2 pipes or 2 redirectors, it actually appends. And we can cat, you'll see the information's in there twice. We now have 4 lines. And we can tally this up. We can actually cat the contents of hello world.text and pipe it into word count, which is one of my favorite tools, and it tells us that we have 4 lines, or with no options, it'll tell us 4 lines, 14 words, 72. Everything should be double what we saw before. Excellent. This is looking good. What else can we do? We can put some more information in the script, so we can grow the script. Let's modify the script, hello world.sh, and let's make the output a little bit more meaningful. Let's say we wanted to echo the date every time the script runs, and we still want to preserve clearing the screen. Well, we'll keep our variables separate, and it's also nice to comment sections in your script. So we'll put a comment that begins the variable section, so we can say here, and there isn't a space required, I'm just doing it for syntax, or to be clean. You can say variables are set here, or begin variables or something. And maybe here we have a comment that says begin code. And then we have our end hiding out down here. So what if we wanted to echo the date? Well, remember, any command you can run from the command line, providing that bash has access to it, and it will, because when we run, when I say access, like the path, for example, when we run this, we're running it as root, and we pretty much have access to everything, and many directories are in our path. Let's say we want to echo the date. So simply throw the date command in, but I want a little formatting, of course, so we want to use %F, capital F that is, and I'd like to get a space, so we'll escape it with the backslash character. We'll put a space, and we'll go with %R. You'll see what happens when we run this. So every time we run this script, it's going to clear the screen, it's going to echo the date, and it's going to echo message and message to. Let's see what happens. Now we're making use of more things. So let's run the hello world.shell script. First line contains a date. This is the %f variable fulfills this section. Our backslash space characters have escaped a space for us between 827 and 06. And we have the time, which is the %lowercase r with the actual time of day. And then we have our 2 lines. And of course, we can echo this information to a file. Let's find it in our history. Here we have hello world.sh. We'll create a new file. Just overwrite the one that's there. We can cat hello world.txt. And the file contains all 3 lines. So any output coming from the hello world.shell script that would normally end up on the screen got redirected to hello world.txt. We get a little fancy. We can send it to hello world.txt, and then we can run a new command. Recall, I told you in order to run multiple commands or sequential command processing, you separate the commands using semicolons. So after doing the redirect, let's cat the contents of hello world.txt to the screen. Excellent. The redirect occurred and we catted the contents. So it appears as if it ran normally when in fact it didn't. We actually wrote to a file hello world.txt, and we can verify that by typing the date. And it just turned 1807, but when the script actually ran, it was 1806 and 59 seconds. So we echoed the date and the information into hello world.txt. We actually created a new file by using one redirect, and then we immediately catted the contents of the file. We could have done other things such as counting or processing or parsing, you name it. Excellent. So you have an idea of how to write a basic hello world script. It's very simple. And let's take a look at it again. Hello world.sh. Here's what it looks like thus far. We have the default bash header. Now this bash header, you may find when you examine other scripts that the header contains /bin/sh, pointing to the classic Bourne shell environment. It's available within the Linux environment. So /bin sh is available, but it's really a redirect or a symbolic link to bash. But when run as sh, you lose some of the functionality of bash. However, bash isn't available on all platforms, so it's a trade-off between portability and features. So for ultimate portability, prefix or include in the header of your shell scripts, especially if you're using Bourne or bash, include /bin/sh. That'll work on Linux and Unix in general, especially if you're not sure or if you're unsure about the presence of bash on a remote system. But for the features, you want to specify, to gain some of the features, you want to specify bin bash. You can go online, look up the bash reference manual at GNU.org, and you'll see many of the differences between bash and the Bourne shell, which is represented by shell, just by sh, which is located on the Linux system in /bin/sh. So this is a simple script. We have some comments, and we have 2 variables, message, message2, and we begin the code by clearing the screen, echoing the date using a format, and the date command requires this sort of format. So I didn't make this up. You just run date. You'll see what happens, how you get the formatting out. And then we simply echo the contents of message and message2. That's it. And we have a simple hello world script. Now we'll be moving on to more complex things throughout the product. Now there are a few other things that we'd like to show you with this hello world script. There are a few other techniques which covers many of the things we've talked about. Let's show you. We're going to modify this file, hello world.sh, and we're going to do some other cool things. Let's say, for example, there was a value that you wanted to get from the command line from the user and echo it using your script. Well, we did show you the read command. Well, we can, somewhere in the script, depending on where you want to use this particular command, you can do it. Let's start with the beginning, and then we can always arrange it so that it's logical. We'll execute something like echo because we want to present what seems to be a question, or present a question, echo a question, and then wait for the input. So we'll say echo, what is your name? Question mark. This should be simple enough. The very next command will be to actually read the variable name or read into the variable name whatever the user types at the prompt. Now, if you want the input to be limited, just check the help on or the man pages for the read command. The read command is a shell built in, so just do man space read and it'll come up. And you can restrict the input like we showed you before, such as the number of characters, etc. So let's see. We're going to read name, and after we've read the name, we'll echo it. We'll echo back to the user some sort of meaningful output, such as, hello name, or it's nice to meet you, or something like that. Hello variable name. So we're doing some simple logic here. We're presenting a question, we're reading into the variable name whatever the user types in, and recall if you need to filter the number of characters, etc., you can specify the n option, -n argument, and then we'll echo it back to the user. Let's Control X to get out of here, and we'll run hello world.sh. So it still continues to do line by line in a sequential fashion everything it has done up to this point, which is to print the date and timestamp, as well as hello world, the world belongs to me. Now it asks a question, what is your name? It's ready for input on a new line. Let's give it the name, or my name, and we'll say it's Dean, and it just echoes back to us, hello Dean. At this point we could have cleared the screen and gone on to do other things, such as, let's modify it to show you, to add some more of a personal feel to it. So at this point we can clear the screen, and after we've echoed, and if you want you can echo new lines, that's fine as well, we can ask another question. Here's a totally different question, and we'll read it into this variable. Perhaps feeling. And we don't need to clear the screen. We'll simply say, you seem, or perhaps you said you were feeling, and then echo the value of feeling, just to make it friendly. Excellent, let's try it. So hello world.sh, what is your name? It's Dean. The screen will be cleared, and now it says hello Dean, how are you doing? I'll say feeling okay. You said you were feeling, I'm feeling okay. Well, fine. You can tell you're dealing with a computer, but nonetheless you understand how to use the read command within your script. Excellent. What else can we do with a simple hello world script to show you some flexibility? Let's modify this file, hello world, get rid of some of this stuff. We no longer need the read command, so we can get them out of here. We've proven our point, which we'll be using read, of course, throughout. Bash, let's do something else. Let's show you how to echo the actual name of the script, including the path. This is good information to store in a log. Recall, if you'd like to store the output of your script to a log file, simply redirect the output stream to the input stream of a file. No big deal. Well, if we were to run the base name command, it'll tell us with the variable, the zero variable, which bash maintains for the name of the script, it tells us. Let's show you how that works. We'll echo script name, and there's nothing special, this is just basic information I'm echoing, but then we'll make use of backticks, of command substitution, to call the base name command. And when you run the base name command and pass in an argument of 0, which the script provides, 0 stands for or represents the current script that's running. So when you run a bash script, it has the ability to accept many arguments from the command line, beginning with 1, because 0 is actually reserved for the name of the script, which is why we're doing this exercise, so I can explain how the arguments work. Typically when you run a command from the command line, a predefined command such as wc, ls, pwd, df, dh, du, ps, you name it, you're able to pass parameters in, arguments in, and oftentimes you can combine arguments for different effects. Well, it's no different with a bash script. With a bash script, each argument that you pass in at the command line assumes a value beginning with 1, and it increments by 1. 0, once again, is reserved for the name of the script. So if we use a program such as base name, it will echo the 0 variable, which is always available. So we could simply echo 0. We'll make it look nice. So we'll say script name XYZ, and it's good to put this sort of stuff in a log. Just in case things change, you can compare and contrast, of course. Let's run hello world, and we'll see what happens. And it tells us script name hello world.sh. All the base name program does is it strips from the file name the path. That's what it does. So in other words, if we were to echo the 0 variable without base name, then you'd see the entire path. But then we should change what we're echoing to perhaps location, like script location. You see it prefixes it with // and the name of the script, because the script is running from our current directory. If we were running the script from somewhere else, then it would tell us from that path as well. Base name just helps to strip the superfluous information. So that's another cool usage within scripts. Let's modify a script as well. You'll be using these things over and over again, such as command substitution, base name, you name it. At this stage, we'll show you how you can do sequential execution, which we've shown you already from the command prompt. And we'll separate a few commands. We'll do 2 commands separated by semicolons. This is where we're able to use the power of bash to process multiple scripts, executables on one line. So the first line will do something such as echo you are currently in the directory, and it will echo the built-in variable pwd. We don't need to do any command substitution here because the shell maintains 2 key variables, pwd and old pwd. They're both stored in uppercase, and they contain locations of the current directory and your previously visited directory, respectively. So we'll echo as a first command, you're currently in the directory, and the bash shell will take care of that. And we'll continue our command chaining here by separating by semicolons the second command. We'll say and. This will happen on a new line, by the way, because we're running a separate echo command. Each echo command, although we're using command chaining, which essentially happens on one line, instantiates a new line, or essentially has a prefixed new line character. So at the end of the first echo, there's a new line character. And we'll say here, and the current local time is, and here we'll actually do command substitution. Although we don't have to, we could easily just do, but the deal is we're doing an echo, so we don't want echo to actually echo the word date. So command substitution works out. And the current local time is date. Now we use the date command to actually get the time, but we pass in not the actual date variable, as in %f, uppercase F, capital F. We'll pass in %lowercase r, and this will return the current timestamp, which is sufficient. So we're making use of command chaining. It will print on 2 lines. If you wanted this to reside on one line, just use one echo statement. That'll work just fine. One echo statement, and the results will appear on one line. Let's see what happens. And let's check that. And the execution you just noticed is because time was actually processed on a separate line, which is why we saw the time run. It needs to be on one line. So time actually ran. Time is a built-in bash command which actually times how long it takes to run a particular script. So let's try that again, and now it'll work. Excellent. So everything's on one line. We've echoed everything. you're in such and such a directory, and the current local time is X because we've passed in the proper value. Excellent. That's not too difficult to understand. So now you know how to do base name to echo the name of a script. You can echo some variables using command chaining, command substitution, you name it. Let's show you how to source a separate file. Let's say we wanted to source a separate file which in itself contained its own commands. Well, let's modify hello world.sh, and we'll continue to work towards the bottom. We're currently not concerned about order. We're more concerned about getting it right. You can always arrange your code to your tastes. Excellent. So let's do some sourcing of, or includes. If you program on the web, you're accustomed to includes. So let's do some bash level includes. How do we go about doing it? Well, there are two ways. We can use a dot to source the name of the file, and that's what we'll show you first, because it's a fancy way and a nice, elegant way of sourcing an outside file. And we can actually type the source command. Both will work. So we'll say dot, and we'll call a file called hello world2.sh, which currently doesn't exist. We're doing it purposely to show you what happens when you try to run this. So everything's going to run. It's going to clear the screen. And here's an error. Right after the current local time is X, it says no such file or directory. You can echo the exit status, and as you can see here, the exit status is 1. Now, rather than bombard you with this information up front, it's better, or I thought it was better to actually show you how the exit status actually works in a script. The exit status is based on the last command that was run. That's important to understand. It's no different than executing the commands at a shell prompt. Each command is mutually exclusive, and as a result provides its own exit status. So the exit status of this entire script, hello world.sh, has failed. It's a 1, simply because the very last command, which is the source, the hello world2.shell script, failed. So it's similar to the analogy that the chain is as strong as its weakest link. Well, one portion of hello world.sh failed, so the entire thing failed, returning an exit status of 1. And again, the exit status is premised on the last command run. Nonetheless, we need to fix this. This is a problem. But I just wanted to show you. If you echo again, it's back to 0 because we ran the echo command. So now we need to actually create the hello world2.shell script. So how do we do it? Well, you can touch a file, hello world2.sh. It contains nothing. You can try running the original hello world.sh, which includes it, echo the $, question mark, and you can see it worked out fine because the hello world.shell script sourced it. It read its contents, although there's nothing to do, but it did read it. Let's give it something to do. We'll pico hello world2.sh, and we need a command. We need to do something. Let's set a variable, for example, message3, and we'll say this is equivalent to we are testing bash includes. And this is not all. We actually need to echo this, because by simply setting the variable, that does nothing for us. We need to echo it. So let's echo message3. And now let's exit and see what happens when we run hello world, the original script that is. Excellent, it works. And maybe wondering, why didn't we have to define the headers within the second file, such as the definition of the interpreter for bash? We'll show you what we mean. Let's head hello world.sh. We'll get the first line. Head is a command that you can run. We'll take line 1. You may be wondering, why didn't we have to actually include this? Because it's already included in the main script. So by sourcing another file, we're simply just calling the contents and executing it within the context of the parent script. So we got it to run, we got it to echo, and we could continue to add things to hello world2.sh and further develop it. So here's a way to split content. You can have one primary script include other scripts, similar to web programming, ASP, PHP, ColdFusion, JSP, Perl, you name it. It's similar in that you may have one script or one main guy, one main script source multiple other scripts for clarity, and then it allows you to separate components and to keep the code nice and neat. So that's how you source files. Let's show you another way to source it as promised. Let's pico it, and this is the wrong file. That's hello world 2. Let's do hello world. In addition to the dot, and we have to show you how to do it different ways, because you'll open more complex scripts and see dot and a call to another file and not understand it. And sometimes script authors aren't nice enough to name their scripts with an extension that is a no-brainer, such as .sh. So you may see something like this, like dot, just hello world 2, and wonder what it does. Well, the other way is you can actually type the command source, but it just doesn't look as elegant as dot. Let's show you how that works. Let's run hello world. It clears the screen for us, and it performs the same thing. So you can use source or dot. So those are some other things you can do. Here's one other cool thing you can do. You can actually dump the contents of anything using standard out to the input stream of some other command. Well, you know you can do redirection and piping. Let's show you what we mean. We're going to run the script, the hello world script, but we don't want the contents to be echoed to standard out, which is the terminal, which is the screen. We want to pipe the output and send it to the mail command. So we're going to make use of mail here. Now let's set a subject. This is how flexible Unix is. It's incredible. We'll set a subject and we'll say testing hello world using pipes, because we're using pipes. And let's send it to someone. We'll send it to the root user. We don't need an internet email address. Excellent. So hello world will send its output. It'll still source hello world 2 and send the output into the mail command, which sets the subject with the S parameter and then just dumps the message into root's mailbox. This would work just as well for someone out on the internet, for example. This would work just as well if your system had access to route outbound messages. Excellent. It ran. We saw no output, so really no indication of whether or not things work. You can echo the question mark variable to see, and it says 0, no errors. Now let's run mutt. Mutt is the default shell-based mail client within a Red Hat environment, and it's quite popular, by the way. There's the message. One new message, August 27th, to root, and the subject is testing hello world using pipes. We'll press enter to read it, and within the body of the message is the output of the particular script. So what you see so far, what you can imagine, is that we're building up to more complexity by making use of similar concepts or simple concepts such as pipes and redirection. We're showing you more and more how you can really administer and automate a system by making use of these simple techniques that Unix Linux provides. So you can do a few things with hello world. What we've just shown you works with all bash scripts. Hello world is just the first example that we work with. We'll be moving on to more complex things such as loops, conditionals for testing, if then else, for loops, while loops, until loops, and other constructs and tools that you need to know in order to effectively use the bash shell scripting environment.